So we're now ready to start talking about the factory method pattern. And this is a very, very important pattern. This is used in pretty much every imaginable well-designed object-oriented program for good reason. And that's because it allows us to be able to create variabilities in a uniform way. And if you recall the discussion we've had before about commonality and variability analysis, this ability to have a common way to create variable things and to do it within a centralized and uniform and consistent API is extremely valuable to make your program simple. Hopefully you've got a little bit of taste for this when you were writing the assignment 4 and assignment 5 implementations, where you could simplify your code dramatically by using the factory methods to create iterators for the various array list objects, and then be able to work with the STL algorithms like copy and fill and so on. And by using those factory methods, you could shield the details of the underlying iterator structure and just focus on the nuts and bolts of calling the appropriate method. And I think you probably agree if you go back and look at the first implementation when you were doing this for assignment 2 and 3, that was way uglier than what we ended up with assignments 3 and 4. So just another example of how factory methods can greatly clean up your code by shielding you from the details of creating objects. So we're going to use this pattern to enable the extensible creation of variabilities. What is a variability? Well, commands are variabilities. We just talked about the fact that there's a good half dozen commands. Those are all variables, but we want to be able to make them look common from the point of view of creating them and from using them. Other things that we're going to be able to have variabilities for would include iterators, would include visitors, and so on. And factory method decouples the creation of objects from their subsequent use. And that's very valuable, as we'll see. So here's just a little bit more detail about all the different types of variabilities. We can have all those different types of user commands. We can have a bunch of different types of C++ iterators. We can have a bunch of different types of visitors. And rather than hard coding those things, we're going to make them creatable by factories. And the reason why this is so important is we want to be able to add new variants to our implementations without affecting the client code that uses the variants in whatever way they need to be used. So what's the problem here we're trying to avoid? Well, the problem here is we don't want to program ourselves into a corner. It's kind of the software equivalent of painting yourself into a corner, as I show here. You don't want to tightly couple the creation of something with its use. And if you take a look at what I show on the kind of the right-hand side of the screen inside the universal "don't do this" icon, you can see how we're going to encapsulate the print command. In this particular case, we would be making a print command or an evaluation visitor or a pre-order iterator. We'd hard code those things into the code. And that means we have lexical dependencies on specific derived classes. So if we want to make any changes whatsoever to our program, we've got a lot of work to do. We have to go to the client code and make those changes, which of course is just unwieldy and inconvenient and not a good way to build your software. So what do we do instead? Well, instead, we're going to define something called a user command factory that has a factory method called make command. And make command is going to create the appropriate user command object. And then that user command object would be used throughout the program. And the same thing would be true for the visitors. The same thing would be true for the iterators. So I'm just using the command as an example because we just talked about the command pattern. But be aware that this concept of factory methods applies to anything, not just to commands, of course. So in this case, we have a user command factory with a make command method that makes some kind of user command. And there's a couple different ways to do this. One way to do this is to subclass from the user command factory to make a print command factory. And then when you call the make command method on that, it makes a print command, but it actually returns it as a user command as opposed to a print command. So that's one way to do it. Another way to do it, which is actually what I prefer and I use in my examples, and I just tend to like it better, is to parameterize the user command factory's factory method, in this case make command, with a string or an enum or a const int, and then have the make command factory take a look at what it's passed and decide which type of user command to make, or what type of command to make in general, what type of product to make to be more general. So in this particular case, as you can see, you can parameterize the make command factory method. And I like this approach a lot more because it doesn't end up with unwieldy hierarchies. So how do we do this? We're going to define this thing called the user command factory, which has a make command method that takes in a string, and that's the factory method make command. So from a commonality and variability point of view, from a scope commonality and variability analysis perspective, we have a common interface or common API to create commands, and then we can have implementations give different behaviors to make different kinds of commands based on the input we give it in our input string. Now we're going to go one step further to make things even more extensible by using this really cool pattern that I love to apply whenever I'm making factories. And what I do is I basically make a map that maps strings to some kind of creational mechanism to make the appropriate type of object that's being requested. So in this particular case, we're going to have this thing called factory PTMF, which is a type def for factory pointer to member function. And we're going to go ahead and have a bunch of member functions that are part of our class, our user command factory class. And when someone comes along and says, I want to make an expert command, we're going to go ahead and call that factory method and execute it to do whatever we need to do. And you'll see this is really, really, really cool, as you'll see in just a second.